I can see myself now. Hello everyone, and welcome to our TWF meetup. So, yeah, kind of weird not hearing myself. All right, so hello, my name is Evgenii, and today on this meetup I will be telling you about RxJS in Angular, and we start from some beginner steps and slightly go to more advanced usages, but still, I still consider it as a beginner level. Also, since I think our time is pretty limited, I wanted to just quickly go through different theory and some. Are there any issues? Okay, seems like everything is good. All right, and so for everyone who is first time with us, just a reminder that the Way Forward community provides a platform for software professionals to discover and explore new trends in the technology field, learn from one another, get inspired, and have fun with fellow professionals. And now we can go to my presentation. So before going to the actual RxJS library and reactive programming, we have to understand some theoretical concepts. So what is reactive programming, right? I tried to find a lot of explanations what it is, and I think the most simplest one and the most understandable one is that reactive programming is programming with asynchronous data stream. And data stream is basically any data that changes over time. And it's important to understand that even the data changed only once, for example, it just went from null to something, then it's also a data stream, right? There was one change, but still, we can consider it as a data stream, and we can do some reactive programming based on it. And here on my screen, you can see some examples from like programming world. What are data streams? So every mouse click, every keyboard event, and for example, even every HTTP request is the data stream. And that's probably like the most useful examples and what you will often see in the but when you use RxJS in Angular. So RxJS is just a library which have this API for asynchronous programming, and it actually exists for a lot of different languages. I will talk about only RxJS, but if you have any experience with other languages and you want to do some reactive programming, then you're free to use any other language. And this list is not even complete here. I think every major language has this library. So let's go to what this library actually has, right? So first example, like first piece of this library is the observable, right? And observable is just an object that contains your data stream. So it changes all the time, right? This observable will emit one or many values. What's very important to understand that the observable by itself is lazy. So until the subscribe method is called on this observable, then it won't do anything. Right? So no code will be executed at all. Here in the code section here, you can see an example of creating a basic observable in JavaScript. It's just a regular object, right, with the constructor that accepts a parameter. Accepts a callback with a subscriber parameter, and that subscriber, it has methods next and complete. So next method, it emits a new value from that observable, and complete, well, completes the observable. So completion means that there will be no any new values coming from that data stream, and every subscriber who is using that observable, well, they can do any logic, or they can just do something based on that, right? Like the last step here, the complete method, it actually is not mandatory, right? Any observable can call this complete method or not, and if it's not called, then this observable is considered infinite, and that's like perfectly normal too. And just in general, this constructor can be used to create a new observable, but I think you shouldn't really use it. And like if you want to create a new observable, there are a lot of different operators that I will talk later. Now, next to observables, there are subjects. So, as you maybe noticed, that observable, it can only like emit new values, right? So you just get the observable from somewhere, you subscribe to it, you get new values, and that's all. But of course, sometimes there are situations when you need to add your data to some data stream. And for that, you can use subjects. There are several types of subjects. The main three one are subject, behavior subject, and replay subject. So subjects, they implement both the observable and observer interfaces, which means that you can subscribe to a subject, but you also can call next method to send new data to the data stream. And what this code means here, right? So we create a new subject, and we are pushing a new value, 0, into this data stream. Then using the set timeout, we're pushing value 1, and after 1 second, we're pushing value 2. And then we subscribe to it. Here, below this code, you can see the diagram that like, which values were emitted, which values we got. So the first question is why we didn't get 0 here. Well, because we subscribed after we pushed this value. So it's, again, very important that subjects, they do not emit any values that existed in that subject before subscription, right? So only after someone subscribed to the subject, it gets the values like 1 and 2 here. Next type of subject is behavior subject, and the difference is that first it requires an initial value. So here you can see that we're passing the default value, -1, like not maybe default, but the first one in this data stream, right? But also this behavior subject, it emits the current value to new subscribers. So if we compare it to subject, it's basically the same code, right? So here on the diagram, we can see that we got this 0, right? Because even though we pushed this 0 before subscription, we still got it, right? Because it was current value at that moment. Also, behavior subject has like a publicly available property value or method get value, and you can use it to access the current value from outside, but many consider this a bad practice, because if you need to access a value from outside, then like maybe your code is not really reactive, and probably you have to refactor something. The third type is replace subject, and it emits last n values to n subscribers, right? So when you create a new replace subject, as a parameter, you pass this n, and when someone subscribes to this replace subject, it gets these n values, right? So it's kind of similar to behavior subject, with the differences that you don't need to provide an initial value, and you can't access the current value from outside. And now we can go to RxJS operators. So RxJS library contains lots and lots of different operators, right? And as we mentioned at the beginning, reactive programming is all about combining different data streams, doing something with them, right? Filtering, transforming them, and so on. And for that, you should use operators. And at the beginning, when preparing this presentation, I selected like the most important ones and the most useful operators. But again, probably we don't have time for all of them, so we'll have to select the most important ones of the most important ones. So let's start from the creation group. Right? So creation operators, they just create the observable from scratch. So of and from, they are very similar, and they create observable from some static value. Of can create a value, an observable from one single value or like multiple of them. It just emits these values and completes. From accepts an array, right? So if you have an array already, then you can use from. From event, it just creates an observable from some JavaScript event. So here, for example, every click inside the document will emit a new value. And you can use every JavaScript event here. Interval and timer are also pretty similar. Right, so interval will just emit numbers every specified period. So here we specify 1000 milliseconds. So these numbers will be emitted every second. Timer operator, it has two modes. So if you pass only one parameter, then it will be just executed only once, right? And then the observable will be completed. If you pass two parameters, then similar to interval, this observable will be infinite. And the first parameter specifies the initial delay, and the second one is the delay between every emission. Now let's go to transformation. Map, very easy to understand. It's very similar to the standard map method on the array in JavaScript. Right? So you just change every value inside that observable. Now, SwitchMap, MergeMap, and ConcatMap, they are kind of similar, but at the same time very different, and it's very important to understand the difference between them. They are often called as higher order observables because they have inner observable and they subscribes to them and flattens them. Right? So, for example, SwitchMap, it is used, for example, when you have some HTTP request that is dependent on another observable, right? And then you can write code like this, right? You have a source observable which emits values, and then you should switch map it to the HTTP get observable. And what's specific to switch map is the cancelable effect of it. So here on the diagram we can see that our source observable here emitted 0, right? Our result observable, it still it gets 0 from the source observable and the second digit from this inner observable. But when the first source observable emits new value, then that inner observable is cancelled, right? It stopped. And we started this timer here again, right? So that's why our second digit here again starts from 0, then 1, then 2, and so on. Contrary to that, merge map operator, it doesn't cancel the inner observable, and here on the diagram you can see that even after our source observable emitted new value, we still get these blue circles with the same with the next values from our source observable. ConcatMap, it waits until the source observable is completed. Right, so as I said, observables can be infinite or not. And well, in this case, since this timer with two parameters is infinite, I had to add another operator, take, which basically makes the observable to complete after five values. And so without it, this code will not even work. We didn't get any value from our result. And here you can see that first we get 5 values, and only then we start to handle the next value, right? So there is a delay between these two like circles of one color, right? And the delay obviously just increases over time. So it's very often when you need to use these map operators, but you always need to think which operator you should use. Next group of operators are filtering. So filter, again, very similar to array filter, right? So we just pass some condition. Based on this condition, values are ignored or emitted further. Distinct until changed, very important operator, right? It just checks that the value is different from the previous one. If it's different, then it comes to result. If it's the same, then it's ignored. Right, so take, as I already explained, it just takes some number of values. Skip, similar to it, skips a number of values, right? Combination operators. Combine latest, I think that's the most useful one. Right? It's just combined two observables and emits their values as an array. One important thing about it that combine latest waits until every observable emitted at least one value. Right? So here on the diagram you can see that even though the first observable already emitted 2 values, the second one did not for some time. So in our result observable we started to get these values only when 2 observables emitted something. Right? But after that we get a new value whenever any of the inner observables emitted something. Fork join, kind of similar to combine latest, but again it waits until all the observables are completed. So again, for that you need 2 observables that can be completed first of all, right? And then you, as a result observable, you can get only one single value, and the observable will complete after that. Merge, very similar, right? But it just emits any value from an observable, and start with just emits one single value at the start of the data stream. Now, utility operators, tab. Well, basically tab can do anything inside of it, right? So it's a very powerful operator, and that's why you need to be very careful when using it. Generally, the tab operator should be used only for side effects, right? So maybe for some logging, or basically for anything that is not related to your general code with your UI, let's say. So delay operator just delays for a specific period of time, and timeout and catch error operators, they quite often are used simultaneously, right? So timeout will throw you an error if the time between 2 different values is longer than some specified value, and catch error will handle that error, and instead of just generic error, will return you some specific value or some specific observable, and so on. And now let's switch to Angular specific functionality. Right? So observables in Angular are used very widely, right? And the most common examples are the HTTP client, router, activated route, and output or event emitter classes. So how does it look in Angular, right? How to use these observables? Well, first of all, you should get this observable, for example, in this case from HTTP client. Right? Then you can subscribe to that observable. Inside the subscribe method, you get the value, and then you can do something with this value. Right? Subscribe method optionally accepts 3 callbacks. Right? So first is success, second error, and the third one is complete. I think like all three of them are used quite rarely. Usually it's just a success one. If you have any errors, then probably you should use catch error operator. And the last step, unsubscribe. So it's written here as optional, but it's like in 90% of cases, it's not really optional. Why? Well, because of memory leaks. So let's demonstrate this memory leak. So let's imagine we have this unsubscribe component, right? So it's a very basic one. It has just a message in HTML, right? And like the message is constructed based on our interval that is emitted every 1 second, and every 1 second this message is updated, and here you can see that every second this message is updated. And now if we go to, for example, to the previous web page, go back, go to the previous one, go back, and so on, and we create a memory snapshot in developer tools, we can see that our snapshot has a lot of instances of that component. Why? Because interval is an infinite observable, and even after the page was closed, right, the component should be destroyed. That observable still emits values, right, so the message object still updated, and our garbage collector basically cannot remove this component from our memory. And so obviously in that case it's a very small component, but of course if you create some big applications with lots of components and every component stays in your memory forever, well, it can quickly grow to very huge memory leaks, right? So we should unsubscribe. Right? How it looks like? Well, the very basic implementation of that is that you can save the result of the subscribe method, which is subscription, into a variable, and inside your ng-on-destroy method, which is called when the component is destroyed, you just call unsubscribe method. Obviously, if you have multiple subscriptions, then it's not really an optimal way, right? So there are several ways how to improve that, and here you can see, well, it's my favorite one, so it's kind of personal preference. And how does it work? So we create a new subscription object, and then every subscription, so every result of the subscribe function, we just add inside that subscription. And then inside our ng-on-destroy method, we can just call one single unsubscribe method, and it will automatically unsubscribe on all internal subscriptions. Obviously, there are different ways to do it, right? For example, instead of just new subscription object, you can create an array of subscriptions and then use for each inside ng-on-destroy and so on. And a very, again, important note to remember that it's always better to call unneeded unsubscribe than not to call a needed one. But in Angular, there is a better way to handle subscriptions, right? And it's Async Pipe. What is Async Pipe? It's a pipe that is built inside Angular, and this pipe will automatically subscribe to your observable. It will later use the values inside your HTML template, and when the component is destroyed, the pipe again automatically will just unsubscribe, and well, you don't need to do anything with it, right? Obviously, Async Pipe cannot be used everywhere, right? Because not every observable goes to your HTML, but I feel like, I don't know, maybe 90% of them are. So wherever possible, you should use this Async Pipe. So if we apply this example to this pipe to our example, then it will look like this, right? So we change our template, we add our Async Pipe, we change our message to observable instead of string, and we remove all the subscribe and unsubscribe methods from our code. Right? So clearly this code is much shorter and better. And that's probably all for theory. Try to keep it as short as possible. And now let's go to an example. Right? So here I've created just a very simple table of TV shows. So we're showing some TV shows, right? By default, it's just popular ones based on rating, I guess. And we can sort this table by every property, right? So by year, by network, by status, by rating. We can click on year and or network to filter by that year or that network. Right? We can reset filters, and we can actually type and get the results. So let's go to the code and see how it works. I hope it's visible for you. If not, I can increase the font. Just let me know. Let me just do that. Okay. If it's still too small, just write it in the chat. So this is our component for shows. Right, we have some static headers, these properties. Right, we have several behavior subjects for every of our possible filters or like sorting values. Right, so for network, for year, for a sorting property, and for search text. We have several methods that are called from our HTML, and well, basically all of them are just updating our behavior subjects, right? And we have helper method to sort shows, which accepts just an array of shows, sorting property, and order. And we also have a service which has only one single public method that returns us all the TV shows based on the provided network, year, and search text. Right. So all our logic here is contained inside our ng-on-init method. So what is done here, right? Well, first of all, let's try to understand it from the reactive programming way. And so we have a data stream of shows, and that data stream is what we see, like the result of that data stream is what we see on the UI. And that data stream is affected by, first of all, by filters, right? So we have to apply these filters. Then using that filters, we have to send a GET request to the API. And then when we get the data, we should sort it using our sorting property. Right, so first step is just to combine all the filters that we have. Right, so here we're using the combine latest operator. We have network year search text, and we SwitchMap it into our get shows. Right, and as I mentioned, SwitchMap is probably what you should use for all your get requests. So after that, inside our shows observable, we already have a list of shows, right? Now we need to sort it. Well, just sorting is easy, right? But we also need to change the order of sorting. How can we do it? Well, to figure out the algorithm, right? The data should be sorted by that property in descending order only in one case, right? If the previous sorting property equals to the current one, and the data currently is not sorted in descending order. So here I'm using, first of all, pairwise operator, which is kind of rarely used, I think. That's why I didn't show it on my presentation, but here I think it's ideal case to use it. And pairwise basically emits you previous and current value of that observable. So every time a new value comes to this sorting property, pairwise will return you previous value and current one. And after that, we use scan operator, which is very similar to reduce operator, reduce method on the JavaScript arrays. Right. So we have an accumulator, which is just order, and based on this, as I said previously, we check that if the sorting property previous one equals to current one, and currently we are not sorting in descending order, then we return true, right? If not, then we return false. And here we're using start with. Why? Because pairwise will not emit any value until there are at least two values inside the sorting property. Right, so start with, it kind of plays a role of default value here for our descending order. Right, so by default it's false, and that's what we start our observable from. And when we get all these like sorting order and sorting property, then again we combine latest our shows, we combine it with sorting property and the order, and we just call in our helper method, and that's all. And the result is assigned to our observable, which is just which can be used inside our HTML here, right? So here in the HTML we just get a list of shows, right? We using ng4, and we're just showing it, right? So it's actually not like the first version of this code, right? So initially, without all this functionality that I wanted to show you later, it should look like this, right? So we don't need a separate operator for it, separate directive, right? We can use our observable inside the ng4 directly, right? And let's check our code. It's still working. Let me check how much time we have. It seems like we're going good. So now let's take a look on how can we improve our table, right? And let's open console, go to network, and well, let's try to search something, right? And what we see a lot of requests. All of them, like except the last one, are cancelled because the observables are cancelable. And obviously we have to avoid it, right? So the basic and well, the best probably way to do it is when you have some input field, and based on the value of this input field you have to perform some request, then you should use the bounce time operator, right? And here we have to add it to our search text observable. And so we just use pipe, and here we're using the bounce time with the parameter. I think usually it should be like maybe 200-300 milliseconds, right? So what does it mean? It means that our search text, like the result of this pipe, will emit values not more often than once in 250 milliseconds. So let's save this code and try it. And we see only one request, right? That's what we wanted. Now let's try to reset the filters, and again we see multiple requests. So why does it happen? Right, let's check our code, and inside our preset filters method we can see that we update 3 different behavior subjects, and since we're using combine latest, right, as you I hope to remember, combine latest will emit new values whenever any of the observables emit a new value, right? So because of we're emitting 3 different behavior subjects here, then our combine latest will get 3 different new values, right? So here again, like one way to do it is to use the bounce time again, right? But in that case, you can use just 0, right? And that is enough, right? Because since all this next method here are executed in the same call stack, then 0 should be enough here, right? So let's try it as well. Okay. All right. So there are 3 requests now. There are only 2. And if we examine this request, we see that the first one contains our query, and the second one does not. Right? And here, like there are again different ways to do it. Right? Generally, before sending some request to your API, which contains some parameters, you should also verify that the parameters were actually changed. And for that, you can use distinct until changed operator. Right? And in our case, we can just add it here. But by default, this operator, it uses just 3 equal sign to compare the object, right? But since here inside our pipe we have an array, we can't use it like with the default compare function because 2 arrays just can't be compared correctly, right? So as a parameter to that operator, we can send our compare function. So it can look like this, right? So we have 2 parameters, first array and second array, right? And we have to return true if these arrays are equal. And I think the basic way to do it probably is something like this, right? So we take every element inside array A and we compare it to element with the same index inside array B. So since objects in our arrays are always sorted like in the same order, right? It's always network, then year, then search text, then we can safely use this compare function. And again, whenever you use this until changed operator, you need to remember that you have to make sure that either you have just a simple string or number, or you have to provide some compare function, right? So for dates, it will be getTime, for example. For arrays, it can be this function. For objects, something else. Maybe you have like a unique property ID, for example. In some cases, you can even use JSON stringify, which is not very performant solution, but well, it works, right? And now we can try it, right? So we select. So let me clear the log, right? So we filter by year, we filter by network, and when we click result filters now, we see only one single request. Okay, so let's go further with our code. As you probably noticed, right, when we click on some filter like year, or let me actually disable the cache to make it more obvious, there is a delay. So not sure if you see it on the stream, but well, obviously it's there because we get some data from remote API. And of course, in real applications, we always use some spinner animation, some loaders for this. So let's try to add it here as well. Right, and the basic implementation for this is to add this ngIf that was here before. Let me just undo my changes. Right, and if the shows observable does not exist, right, then we can use we can show some loader template. And now we create this template, and we use just matte spinner. That's the spinner from Angular material for this. Now let's try it. And again, not sure you are able to see it, but there is a spinner when you open the page for the first time. But obviously, if we click on a year or network, then the spinner does not exist. Right? Well, why? Obviously, because at that moment we already have something inside our shows, and we don't change it to null something right before our request. So inside our HTML, there is always something inside the shows variable. So we have to do something in our code for this. And again, one of the ways to do it, maybe not the ideal one, but it's what probably for this case would be the most easiest one and the most fastest to create. And we can use just a separate behavior subject for this. Right? So let's call it isLoading, and again it will be behavior subject of type boolean, and the default value can be false, can be true. Actually, it won't really matter for us. And now, before we do our actual HTTP request, which is done inside the SwitchMap operator, we need to update the value of this isLoading behavior subject. And we can do it with that tab operator. Right, so should do it like this. Let me just tab, and after SwitchMap, we change it back to false. Right. So now our TypeScript is ready, and we need to update our HTML for this. It can be done very easily here, right? Just we need to invert our isLoading observable. Right? So if not isLoading, and of course we use Async Pipe here. And more brackets. Yes. And now let's try it. Sorry, this should not be should be like this, right? So we should not use Async Pipe twice in the same observable. We should use that variable we get from the Async Pipe. And now we can see the loader animation when we load the page and when we click on any filter, right? Yeah, so works perfectly. Now let's take another look on our code. So if, like, for one single case, this usage of tabs is perfectly normal, right? But if you create a big application, well, not even big, just an application with more than one component, you probably don't want to use this type this tab every time, right? And for this case, you can create a custom operator. So our custom operator should automatically tap the value inside our isLoading behavior subject, then use SwitchMap, and then tap false, right? So the easiest way to do it, and like since we know that our custom operator should be based on SwitchMap, we can just go to SwitchMap definition and copy it type and create a function. Right? Yeah, now we can see it. So we should rename it something like SwitchMap with loading. We should add all missing imports. And as a parameter, so aside from our project callback, we also need to add this exact, this behavior subject that we're using, right? So here inside that that function, it can be just a subject. It doesn't really matter for us. Oh, let's make it just a subject of Boolean, and inside that function, we should use a pipe function, right? So it's just like an operator that pipes another operators. And the first would be again like our tab. So next true. Right. Then we use SwitchMap, and to SwitchMap we pass our project callback, right? And then again tab. Yep, that's it. And now we can just reuse this operator instead of our switch map. Right, we should add our behavior subject. And we can remove these tabs from here. And we can check our code, and it still works. So, like this one perfect example, it's works good for this case, right? But obviously, if you have some complex logic, if you have maybe some custom loader, or if you have maybe some error component, right, which should be shown if your request failed, then of course you can change this code, right? So instead of just one single custom operator, you can create directives and so on and so on. But that's like the basic example of how you can create custom operators. And I think that's all with the theory. And like our small example, looks like I'm a bit over the time. Now we can go to some questions, first of all, from me to you. As far as I know, we have 3 books to give to you, and to get any of them, you have to probably I did it wrong way, right? So there are 2 questions for you, right? So first of all, what does RxJS stand for? And the second one, you can see the following code here. So when and why we'll see an alert on the page, and you should reply to our chat, and I think who does it first gets a book. And I think that's all from my presentation, and I think we can go to Q&A session. And I guess I should just, I will switch to YouTube chat and I will read your questions. And answer them. Okay, so first of all, in the chat I see messages that I've missed the zip operator and probably some others, but as I said, I just wanted to go faster through it. This like presentation with all the slides will be available on GitHub, so you can check it there. Another question is about why I'm using BehaviorSubject all the time. That's a good question, and it's not really required here, right? But there are like two ways to do it. So either we're having BehaviorSubjects here with the default value, which will be emitted as the first one, or the second option, we have to here for every filter we have to add start with operator, right? Because combine latest will not emit anything until all of them will emit something, right? So we need some initial value. I went with BehaviorSubject just because it's shorter to write and probably shorter to implement, sorry, to understand. But doing it with start with also perfectly valid solution. Yeah, so it looks like we still don't have an answer for the second question. Let me actually go back. And we got the, I guess, the response. Sorry, my headphones turning off. So, do you have any questions? Any other questions? If not, then I guess probably we can finish. Yeah, so sorry, I forgot to explain, right? So just to tell the correct answers, so RxJS is Reactive extensions for JavaScript, and the following code. So yes, it's like a tricky question. As I said, without subscribe method, nothing will be executed. So we don't have any subscribe here, so nothing from here will be done, and we won't see alert never. And yes, so if you use async, then sure, you don't need to call subscribe, but that's why this is like the exact code inside ng on init. And as you see, we don't assign this observable to some variable, so we can't even use it inside our HTML. So if it would be assigned, then of course inside our HTML we could use the async pipe. All right, guys, I think that's all. Right, so thank you for listening, for watching. I hope it was useful for you. So the links to this presentation and to source code actually will be available on my GitHub, and I think the links could be added either to this comments in this video a bit later. Right. So yeah, thank you all, and see you in the next TWF meetup.